Solving systems of loop equations with a graphing calculator. When we left off in the previous video, this was where we stood. We had guessed that there were several unknown currents here, and logically we figured out that the current then going through this R2 would be numerically equal to I1 plus I2. So let's write some loop equations. Since we have two unknowns, we have to write two loop equations. I'm going to go around the left loop, and I'm going to start at the dot, and I'm going to go counterclockwise. I'm going to start right there at that dot, and I'm going to go counterclockwise around this loop. So this is what we would get. We run into that battery first, E1, and then as we go this way, we're traveling in the same direction as our assumed current. So we're going to go minus I1 R1 as we go through that resistor. And then we're going to go back up. Since we're only doing the left loop here, we're going back up through R2 now. We are also traveling in the same direction as our assumed current is going. So we have minus IR there. And now we're back to our dot. So we write 0. If we put the numbers in there, then E1 is 12. And then we have R1 is 4. So this is 4I1 minus, and then we have I1 here times R2. So that's going to be another minus 3I1 minus 3I2. And that's going to equal 0. These obviously can be combined into a negative 7 I1. When we're all done here, what we have is, if I can fit this in, 12 minus 7 I1 minus 3 I2 equals 0. That's what that loop equation has given us. Now we have to write a second loop equation. We need two of them because we have two unknowns. So this time I'm going to draw a little star right there, and I'm going to go around the right loop, and I'm going to start and end at the star. Very often I like to travel in the same direction that my assumed current is going, but you don't have to. Let's do that. We're starting at the star, so the first thing we run into is battery number 2, and then we're going to end up with minus I2 times R3, and then we're going to go minus I1 plus I2, that quantity multiplied by R2, and that's going to equal 0. If we put those numbers in there, I'm getting that this is 7 minus 6I2 minus 3I1 minus 3I2 equals 0. If we combine that, we combine this into our first loop equation. Our second loop equation then is going to be 7, and I'm going to put the I1 first, minus 3I1 minus 9I2, and that's going to equal 0. Those are our two equations, and what we're going to do now is we're going to use our graphing calculator to help us solve those. The way we do that, we need to arrange the variables to the left of the equal sign, constants to the right. You can see what we've got here. We're going to put variables on the left side and the constants on the right. So the 12 needs to go on the other side where it becomes a negative 12, but then everything's negative. So essentially we have 7, 3, and 12 for that first equation. Variables on the left, constants on the right. The second equation, the 7 will go on the right there. It'll be negative, which means everything is negative. So I'm just going to multiply by negative 1 throughout, and we'll get 3, 9, 7. We want to make sure our I1s are lined up, our I2s are lined up, etc. And we're going to enter these equations into the calculator as, in this case, a 2x3 matrix. These are the buttons that we push. I'll go through these quickly, and then we'll show you them and give you the answer here. So you hit your second matrix button, you toggle over to edit, hit enter, type in the size of your matrix, which here will be a 2, 3 matrix. We're going to type in the numbers left to right, like reading a book, and hit enter after each one. And this is going to be stored as matrix A. We need to quit out of that. Then we go back into matrix. We're going to toggle over to math. Don't hit enter. We're going to toggle down, it's quite a ways, to RREF, which stands for something like reduced echelon form. We're going to hit enter. Then we go to second matrix and hit enter. That inserts matrix A in there, and you hit enter a few times, and boom. The values of I1 and I2 are there. Let's show you that real quickly here. If you recall, here was the system of equations that we need. Let me zoom in just a hair. All right, so here we go. We got to hit our matrix button. So you go second matrix. We're going to go over to edit. And we're going to hit enter. This is a 2 by 3 matrix. So I'm going to go 2, 3. I'm going to hit enter. Now we're going to enter our numbers just like a book, starting left to right. 7, enter. 3, enter. 12, enter. 3, enter. 9, enter. 7, enter. All right, let's quit. Now we go back into matrix. We're going to go over to math, and we're going to toggle down quite a ways until we get to RREF. Boom, right there, RREF. Now we'll hit enter. Now we need to tell it to put matrix A in there. So we're going to go second matrix and just hit enter. Oop, there. It has put matrix A in there. Now we're going to hit enter one more time. There we go. These are the answers that we get. So I1, we got to be 1.61 amps, and I2, we got to be 0.24 amps. So let me write those answers right here. I1, 1.61 amps, and I2 is 0.24 amps. Those were the currents that we got. And because they turned out positive, that means that we happened to choose the right direction for those currents when we were doing this. We happened to choose that current went the right way, and so did that one. If the currents come out negative, it just means that we guessed wrong when we wrote our original direction for the current. No problem, no big deal. Now, if this question had been, what's the current through R2? Then you would have to add your 1.61 amps right there and your 0.24 amps, because what's going through R2 is both of them.